Okay, we have a problem here with Kyle, and he's going on a flight. All right, so in this story, Kyle drives 26 miles south to get to the airport, and then he takes off in an airplane that flies 6 miles east and 2 miles north every minute. And after 2 minutes, he's over top some nearby town. And the question is, how far is that nearby town from his home? And then later on, he flies over something that is, let's see, how far was it from his home? Hold on, I'm going to pause this. Okay, 34 miles. At some point, Kyle is 34 miles from his original starting point, and when does that happen? All right, and this is a bit of a doozy, so let's get started. First, bring this up a little bit. Let's just start by putting this whole problem on a coordinate grid. I'm gonna put my y-axis here, put my x-axis here. Now we could start Kyle anywhere in the grid and reach it and get it. And we don't even actually need the coordinate axis. I mean, we could do this without it, but it's going to make it a lot easier. And we're going to have him start up here and drive south, and the airport's going to be at the origin. Again, we don't have to do it this way, but it's going to be helpful, I think. So he's driving 26 miles south, which means he starts 26 miles north of the airport. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, going off the screen here, 1, 2, 3, 4, 5. Here is his home at 0, 26, home. Okay. Oh boy, adjust this to get everything on the screen. That should be good. What? Phew. The graph is big. Yeah, all right. So here he is at home, and we're going to be traveling south. I wonder if I could, yeah, whatever. Okay, so let's see. His plane leaves the airport, and it flies 6 miles east and 2 miles north. So let's see. 1, 2, 3, 4, 5, 6, and 2. And I'm just going to mark off the x-axis here. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just kind of, yeah, all right. So 6 miles east, 2 miles north. So this is the point 6, 2, and t is equal to 1. And here at the airport, we're at 0, 0, and t equals 0. That's the takeoff time. 1, 2, 3, 4, 5, 6, 1, 2. So this is 12, 4, and t equals 2. And 1, 2, 3, 4, 5, 6, and up 2. So here's 18, 6, and that's t equals 3. 1, 2, 3, 4, 5, 6, and up 2. And this is 24, 8, and that's t equals 4. And then 1, 2, 3, 4, 5, 6, 1, 2. That's 38, and that's t equals 5. We'll stop there. Okay. So here's the path of the plane. Let me just get a ruler here. I'm gonna connect these with a nice line. I just feel like doing that. It's gonna look nice. So let's see here. There we go. Up a little arrow there. We're continuing in that direction. All right. So the first question is, at 2 minutes, sorry, he's over top this town right here, and the question is, how far is that from his home originally? So what we're going to do here is I'm going to connect. Okay. I'm going to connect that point here with his home. And I'm going to use a dotted line for this just to kind of differentiate it here from the other lines. Okay. And we want to find out how far that is. Well, finding distance between points in the coordinate plane, the good old Pythagorean theorem. So I'm going to go over here. I'm just going to, you don't have to draw this in, but I'm going to. And let's see. This is 26, and this is 1, 2, 3, 4. So 26 take away 4 is 22. And here, this is 12, so 12 spaces over. It's 12. So using Pythagorean theorem, a squared plus b squared equals c squared. 22 squared plus 12 squared equals c squared. And we're just going to let the calculator do all the heavy lifting at this point. So let's see, we've got 22 squared plus 12 squared is 628. So we have square root of 628 equals c. And I don't think that's not a whole number. Nope, but about 20.06. So I'm going to write here on the side of this, we're going to write c equals square root of 628, which is approximately, what was that, 25.06. Okay. I'm also want to calculate this using a different method. I want to use the distance formula. And the reason I want to use the distance formula is because we're going to use the distance formula later on. So let's go ahead and do that. With the distance formula, it's essentially Pythagorean theorem, but instead of plugging in the side lengths, we plug in the coordinates. You notice how the 12 here told us that we were 12 spaces from the axis, and we're going to use that in the distance formula. So up here, our distance is equal to x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. That's going to walk you through this, and we'll see how this ends up being the same calculation as we did with Pythagorean theorem. So distance is, so our x, so we're going to use over here, x1, y1. And down here will be x2, y2. So that's the first point. Down here's the second point. So let's see. Our x sub 1 is 0. And our x sub 2 is 12. And our y sub 1 is 26. And our y sub 2 is 4. And you notice how we're going to have 0 minus 12. That's going to give us negative 12. And you see the connection there that we're 12 spaces away, what we calculated earlier just by counting spaces. And we did that by saying, well, this coordinate's 12, this one's 0, so they're 12 spaces apart. That's where this 12 is going to come from. And here, 26 minus 4, well, we knew that this was 26 spaces up, and that this line here was 4 spaces up, so 26, take away these 4 spaces down here, leaves us with 22. So you can see how the distance formula is doing the same calculation we did with Pythagorean theorem, it's just it does it without the counting spaces part. And the fact that this is a negative 12 instead of a positive 12 isn't going to matter after we square it, for starters. And second of all, the reason it comes out as negative is because when you're subtracting, you're not calculating distance, you're calculating displacement. And what that means is that what we're calculating is we travel from here to here. We're going backwards, so it's negative 12 spaces. But again, after we square it, that won't matter. So then we get d equals square root of negative 12 squared, 22 squared, and from here, d equals, and this is going to be 144, and whatever 22 squared is, 484. And so d equals square root of 144 and 484, which is 628. So we get the same answer either way. The only difference is here with Pythagorean theorem, we had to have the graph, we had to count spaces. And here we had, we just enter the coordinates, and the coordinates kind of do that space counting for us. This method here, more opportunities for mistakes because there's more calculations to do. But I don't need a graph to do this. I just need the coordinates, no graph. Okay, so we found that at t equals 2, at 2 minutes into his flight, Kyle is about 25 miles away from his home, from where his original starting point is. We use Pythagorean theorem to calculate that. And the next thing that we're supposed to find, to make sure we're okay. So the next thing we're supposed to find is where in Kyle's flight is he 34, I think it is. Yes, 34 miles from his home. That's going to be a little more complicated. What we could do is we could just do that same calculation we just did using the point 18.6. So let's go ahead and I'm going to go ahead and set that up. So I could say I'm going to test the point 18.6 to see if it's 34 miles from his home. Okay. So I'm going to go distance, and I'm going to use this still as x sub 1, y sub 1. So I have 0 minus, this time 18 squared plus, let's see, 26 minus, kind of off screen there, 26 minus, see it's 6 squared, and that's all going to be equal to, let's see, 0 minus 18 is negative 18, and 2 minus 22 minus 6 would be 16 squared. And so I'm just going to use the calculator at this point. Let's see, 18 squared plus 16 squared gives us 580. Square root of 580, which is not 34. So it's not that point. Let's try the next one, 24, comma 8. So let's see, we'll do distance. All right. We're still going to use this as our x1, y1. So we've got 0 minus 24 squared. And then over here we've got 26. 22 there. That should be 26. Oh, 26 minus 6. Oops, I made a mistake. 20 and 18 squared plus 20 squared is 724. But still not 34. All right, 26 minus 8. All right, and that's going to be, let's see, 0 minus 24, negative 24 squared. 26 minus 8 is 18 squared. So let's see, D equals, let's try, let's see, 24 squared plus 18 squared is 900. Let's see, so square root of 900, oh, that is, that's 30. Okay. Pause for a second. Okay, I just hadn't realized that we were going to come across another whole number before we got to the actual one, which is the next one, so I was a little surprised there. So D equals 30, but we're looking for 34. All right, so let's try the next point. Wonder if we'll find it here. So let's go. Distance equals, let's see. This is still our point 1, so 0 minus, this time 30 squared plus 26 minus, this time, and that's a 10 there. I made another mistake earlier when I noticed that that y coordinate was wrong the way I'd written it down. So it's 10 squared. D equals negative 30 squared plus 26 minus 10 is 16 squared. And let's get our calculator out here. We have 30 squared plus 16 squared is 1156. So square root of 1156. And D equals, just to take the square root of that, because it is a whole number, 34. 34. So here, at this point, at this time right here, Kyle is 34 miles from home. We use Pythagorean, well, we use distance formula, Pythagorean theorem, to calculate that distance. So that's the distance from this point to his home, right, using distance formula. Now we had to do a lot of guess and check, and there's a possibility that we would have skipped over it. I mean, we don't know for certain. It could have been, there's a point right here, or maybe a point down here. So jumping from one, where he is at 1 minute, 2 minutes, 3 minutes, 4 minutes, we don't know that he is going to be exactly 34 miles from home at any whole number minute. It could be like 3.5 minutes or 3 minutes, 47 seconds or something like that. So we could have gone, oh, well, here we're at 30 miles, and we could have gone up to the next, minute value, whole minute value, and found we were over 34 miles, and then we'd have to go back. So that's one of the problems with guess and check. Guess and check is a great tool, but it can be troublesome if the answer is something obscure or weird that you're never going to guess. So let's look at a more direct method for finding this. Notice in these calculations a couple things. One, here that our x1, y1 is 0 and 26, 0 and 26, 0 and 26, 0 and 26. So those numbers are the same every time we do the calculation. So we're going to use that fact to start setting up a formula that we're going to set up a formula and an equation and solve directly for the number we're looking for. So we're going to set up our distance formula equation. D equals, and then we're just going to hardwire 0 minus x plus 26 minus y. So we're hardwiring the 0 and the 26 right in there because they're the same in every calculation. We're not calculating the distances to any random point. We're calculating specifically the distance to the point 0, 26. So next, we want to be able to describe the xy coordinates of the plane in terms of the time. Well, we know how to do that. That's writing a parametric equation. And here, it's fairly simple because we're starting at 0. So our x coordinates, if you'll notice, time is 1, x is 6. Time is 2, x is 12. Time is 3, x is 18. So our x value is always the time times 6. So x is equal to 6 times time, or 6t. And y, when time is 1, y is 2. When time is 2, y is 4. When time is 3, y is 6. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6, and so on. So our y coordinate is always 2 times the time. So now we have x and y for every point on that line in terms of the time. And I can go back into our equation, and now I can replace x and y with expressions that are in terms of t for time. So we have here 0 minus 6t squared plus 26 minus 2t squared. And what distance are we looking for? We're looking for when distance is 34. Now we just have to solve this equation. When does 34 equal, or what value of t will give us 34? So first thing we need to do is square both sides of our equation. I'm kind of leaving the d out here. And we already know that 34 squared is 1156. So we've got 1156 equals, and this 0 minus 6t is just going to become negative 6t squared plus 26 minus 2t squared. So next I'm going to expand this binomial, and we'll get rid of this. We'll open this up here. So 1156, this becomes 36t squared. So I'm squaring both parts, the negative 6 and the t, plus, let's see, it'll be 26 squared. 26 squared, which is 676, plus 26 times 2 times 2. So let's see, that'll be 26 times 4. Make sure I'm not making any stupid mistakes here. 104 minus 104t, and then plus the 2t squared, so that's 4t squared. So then we have 1156 equals, let's see, 4t squared and 36t squared. That's 40t squared plus, actually let's write this, minus 104t plus 676. Now I'm going to subtract 1156 from each side. I get 0 equals 40t squared minus 104t plus, see, so we have 676 minus 1156 gives us negative 480. Okay. Oh, that should be negative 480. Now I can divide all of these by, let's see, 104, 480. So we can divide them all by 4 easily. So let's see, we have 0 equals 10t squared. 104 divided by 4 is 26. 26t, 480. Wait a minute. Yeah. 480 divided by 4, 120. Looks like I can still divide by 2. So that's 5t squared minus 13t minus 60. And at this point, I think I've divided everything out I can. I'm going to have to solve the equation. Now there's a lot of different methods we could use here. I'll say you could use the quadratic formula. You could use some sort of factoring method. That probably quadratic formula is your best bet. But I'm just going to skip to the part where we're going to show that t equals 5 is a solution to this equation by plugging 5 in. So 0 equals 5 times 5 squared minus 13 times 5 minus 60. And let's see, 0 equals 5 times 5, so 25, that's 125 minus 65 minus 60. And indeed, 125 minus 65, 125 minus 65 minus 60 is 0. So 0, check. So what we've done here is we've shown that 5 is a solution to this equation. And so if it's a solution to this equation, and we've done all our steps properly, then 5 will also make this statement, this one, this one, this one, this one, this one, all the way back to here. 5 will make this original statement true as well. So 5 is the value of t that I would plug in to this formula in order to get a distance that's equal to 34 units. So I know this is a long process, but again, it goes like this. We set up our distance formula, and we hardwired in the coordinates of Kyle's home, and then we rewrote x and y as expressions that involved t. So x is equal to 6t, y is equal to 2t at any given time. And then we set that equal to 34 miles because we're trying to find when is it going to be 34 miles away. Then we go through this long, complicated equation solving process to finally get t equal to 5. Right? Well, we didn't actually finish the equation solving process, but again, we could use Pythagorean theorem, or not Pythagorean theorem, sorry, quadratic formula to get that. It would, by the way, also give you a second answer, which would be some sort of negative fraction, which means that there is another point on this line, which is back here somewhere, which is also 34 units from his home, but since the plane isn't flying in that direction, it doesn't really matter for us. All right, it's a lot of work.